Imagine a place where the earth itself refuses to be crossed, where the ancient karst mountains of southwestern China rear up out of the ground in jagged, impossible limestone towers, and where a single, brutal canyon cuts so violently deep into the landscape that for centuries it completely isolated entire villages from the modern world. This is Pingtang County, a remote, deeply impoverished pocket of Guizhou province, sitting more than 2,000 kilometers from the gleaming skyscrapers of Beijing, buried in a labyrinth of fog-choked valleys and vertical rock walls that no ordinary road could ever hope to conquer. At the heart of this brutal terrain lies the Guizhou River Grand Canyon, a colossal, gaping wound in the Earth's crust, plunging over 300 meters straight down to a violent river carving through solid stone. For generations, the people trapped on either side of this canyon lived in a state of permanent, punishing isolation, forced to travel for hours along treacherous mountain switchbacks just to reach a market, a hospital, or a school that should have been minutes away in a straight line. The Chinese government looked at this brutal geological nightmare and made a deeply arrogant, almost impossible declaration. They were not going to build a road around the canyon. They were going to build a bridge directly over it, a bridge so violently tall that its towers would pierce straight through the clouds themselves, permanently erasing centuries of isolation and stitching this poverty-stricken region into the beating economic heart of modern China. This was the birth of the Pingtang Bridge, a 2.135-kilometer cable-stayed megastructure that would ultimately be crowned with the tallest concrete bridge tower on the entire planet. A brutalist concrete leviathan built not for spectacle, but for pure, unrelenting human survival. The absolute terrifying core of this entire megaproject was the impossible task of building a foundation on the edge of a cliff that seemed determined to swallow anything placed upon it. Standard bridge construction relies on flat, stable ground to anchor colossal concrete piers, but the Guizhou River Grand Canyon offered no such mercy. Its walls were a chaotic, crumbling mixture of exposed limestone karst, riddled with hidden sinkholes, underground caverns, and unpredictable geological faults carved out by millions of years of acidic water erosion. Before a single tower could rise, structural geologists had to descend into this violent landscape and conduct an exhaustive, borehole-by-borehole survey of the canyon walls, drilling deep into the rock to map out hidden voids that could catastrophically swallow a foundation mid-construction. Engineers discovered that the karst terrain was so unstable in certain sections that standard pile foundations were completely unusable, forcing them to relocate anchor points and redesign load paths on the fly, a level of real-time structural improvisation that would have been unthinkable on a conventional flat-ground bridge project. Massive drilling rigs, hauled up narrow, barely accessible mountain roads on the backs of heavy transport trucks, had to be assembled piece by piece on precarious cliffside platforms, bolted directly into the rock face hundreds of meters above the canyon floor, because there was simply no flat ground anywhere nearby to stage a conventional construction yard. With the geological survey complete, the engineers turned their full, terrifying focus toward the single most audacious element of the entire megaproject: the construction of 3 colossal cable-stayed towers, each one designed to rise directly out of the canyon's cliff edges like brutalist concrete spears aimed at the sky. The central tower alone was engineered to reach a staggering height of 332 meters, a number so mathematically absurd that it would ultimately crown it as the tallest bridge tower made of reinforced concrete anywhere on the face of the earth, as tall as a 110-story skyscraper standing in complete isolation on a mountain ridge. Its 2 flanking towers were not far behind, rising to 320 and 298 meters respectively, forming a symmetrical trio of concrete monoliths that would eventually anchor the entire suspended highway. Building a concrete tower of this scale is an entirely different discipline from building one on solid urban ground. Every single vertical section had to be poured using a highly specialized slip form and climbing formwork system, where a moving steel mold would climb the tower incrementally, section by section, allowing workers suspended hundreds of meters in the open air to pour, cure, and reinforce each new segment before rising higher into the thin mountain atmosphere. The wind at these extreme altitudes was a constant violent enemy, gusting unpredictably through the narrow canyon corridor and threatening to destabilize the climbing formwork with every new pour. Engineers had to constantly monitor real-time wind data and halt concrete pours the instant gusts exceeded safe thresholds, turning every single day of tower construction into a tense, high-stakes negotiation with the mountain's own violent atmosphere. Inside each of these 3 colossal towers, structural engineers embedded an intricate, deeply reinforced steel skeleton, a dense lattice of rebar cages carefully calculated to withstand not just the immense static weight of the deck and cables above, but also the dynamic, unpredictable forces of wind shear, seismic activity, and the extreme thermal expansion caused by the region's dramatic temperature swings between freezing winter fog and blistering summer heat. Because the towers were being built directly on the crumbling edge of a canyon wall, rather than on stable open ground, engineers also had to account for asymmetric loading, a terrifying structural reality, in which one side of a tower bears dramatically more stress than the other, simply because of the uneven terrain beneath it. To solve this, the base of each tower was anchored using massive, deeply excavated caisson foundations, some driven dozens of meters into the rock itself, distributing the tower's colossal weight far beyond the fragile surface layer and into the deep, more stable bedrock hidden below the karst. With the three towers finally standing complete against the misty Guizhou skyline, the engineers launched into the second brutal phase of the mega-project, spanning the terrifying void between them using a network of high-tensile steel cables and a cantilevered deck construction method that required absolutely zero room for error. Unlike a suspension bridge where cables drape continuously between anchor points, a cable-stayed bridge like Pingtang relies on dozens of individual steel cables radiating directly outward from each tower, fanning down to support the roadway deck like the strings of a colossal brutalist harp stretched across a canyon. Each cable had to be manufactured to an exact, non-negotiable tension specification, because even a fractional miscalculation in a single cable could throw off the delicate structural balance of the entire deck, causing dangerous torsional stress to ripple down the length of the bridge. Specialized cable installation crews worked from small, terrifyingly exposed platforms suspended directly off the towers themselves, hundreds of meters above the canyon floor, threading each cable through its anchorage point and torquing it to precise tension using heavy hydraulic jacks, all while battling the same violent, unpredictable mountain winds that had plagued the tower construction. As the cables were installed, the deck itself began to grow outward from each tower in a method known as balanced cantilever construction, where matching segments were added simultaneously on both sides of a tower to keep the entire structure in constant equilibrium, preventing it from catastrophically tipping under its own asymmetric weight before the final connections were made. Each new deck segment, a massive prefabricated steel and concrete composite panel, had to be hoisted into position using specialized launching gantries mounted directly on the previously completed sections, inching the roadway further and further out over the terrifying open canyon air with each successive lift. The final, most dangerous moment of this entire phase arrived when the outward growing deck sections from two adjacent towers finally approached each other in the middle of the canyon, separated only by a narrow, shrinking gap suspended more than 300 meters above the raging river below. Engineers had to account for thermal expansion, cable creep, and even the subtle sag introduced by the deck's own weight to ensure that when the final segment was lowered into place, it would align with millimeter precision, permanently locking the entire 2.135-kilometer structure into a single, continuous, self-supporting highway, suspended impossibly high above the earth. The total width of the completed deck reached 30.2 meters, wide enough to accommodate a full two-way, four-lane expressway designed for speeds of 80 kilometers per hour, a staggering contrast to the narrow, winding mountain paths that had previously been the only way to cross this brutal terrain. Beneath the deck, the road clearance above the river reached an almost incomprehensible 310 meters, placing Pingtang Bridge among the very highest road crossings ever constructed by human hands. Local residents, watching the towers and cables rise out of their ancestral canyon, began referring to the structure by a hauntingly beautiful nickname, the Cloud Bridge, because on foggy mornings, a common occurrence in this humid mountain region, the dense mist would roll directly through the canyon at deck height, completely swallowing the roadway in a thick white shroud while the three towers pierced upward into clear blue sky above, creating the surreal, almost supernatural sensation of driving directly through the clouds themselves. Financing and executing a mega-project of this scale in one of China's poorest provinces required an equally massive logistical and financial mobilization. The total investment for the Pingtang Bridge reached 1.5 billion yuan, equivalent to approximately 215 million US dollars, a staggering sum for a single structure, but a relatively modest figure when measured against the sheer scale of the engineering challenge it overcame. Construction officially began in April of 2016, and in a testament to the relentless pace of modern Chinese infrastructure development, the entire megastructure, from the very first borehole survey to the final asphalt layer, was completed in under 4 years, with the main bridge closure achieved by September of 2019. Thousands of workers, engineers, and heavy equipment operators lived in temporary mountain camps for years, enduring isolation nearly as severe as the very communities the bridge was designed to save, all in service of a single unifying mission, connecting Tongzhou on the canyon's western rim to Yazhou on its eastern side, forming a critical link in the broader Pingtang-Lodian Expressway network designated as the S26 route within the Guizhou provincial highway system. When the Pingtang Bridge officially opened to traffic on December 30th, 2019, it did not merely connect 2 points on a map. It fundamentally rewrote the economic future of an entire region that had been trapped for centuries in a cycle of poverty, directly caused by its own impossible geography. Journeys that had once required hours of dangerous switchback driving through the mountains were suddenly reduced to a matter of minutes, allowing local farmers to transport goods to market before they spoiled, giving students reliable access to schools on the opposite side of the canyon, and opening the region to a wave of tourism, drawn by the sheer, jaw-dropping spectacle of the world's tallest concrete bridge tower, rising directly out of a fog-filled abyss. The bridge was quickly recognized by international engineering bodies and awarded some of the highest honors in global civil engineering, a formal acknowledgement of the sheer audacity required to plant a 332-meter concrete spear into the crumbling edge of a karst canyon and expect it to hold. Today, the Pingtang Bridge stands as an undisputed monument to brutalist mega-engineering, a permanent 2.135-kilometer testament to the idea that no canyon, no matter how violent or how deep, is truly impossible to conquer with enough precision, enough steel, and enough raw human willpower. Every single day, thousands of vehicles now cross silently through the clouds, hundreds of meters above a river that once represented an absolute, unbreakable barrier, driving directly over one of the tallest bridge towers ever poured from concrete on planet Earth, a structure that transformed an isolated pocket of rural China into a permanently connected node within the largest infrastructure network the modern world has ever built.
I'm getting a solid reading on this weld joint now.
Look at this part right here. It's incredible what they accomplished.
Truly a marvel of engineering.
Yeah.
I had no idea it won so many awards.
That'll be $5. Thank you, it smells amazing.